we are ventilating the load lock. There is a 10 different places that you can put 6-inch wafers and give them dedicated names, and takes approximately 5 minutes to ventilate the load lock. So now we have to take this cassette out of the chamber. Still lifting it up. It's a little bit heavy. You put it on the table, and now you are ready to load your sample. So now we have a stage with the small sample. We mounted it fast. So now we put it into this carrier ring, upside down. And this is 6-inch adapter ring. This now gets into the cassette. Like this. Take this cassette back into the load lock, and it's critically important that you put it in the right direction. So you're not putting it like that, but you're putting it this way. So as you see, you place it into load lock. Remember, it's a little bit heavy. Adjust it and verify that it sits correct. Now, you see, once this wafer is taken by the robot, it comes this way, so it has to have a place for the arm to get into the cassette and take it. So remember to place the cassette in the correct direction. Now I close it, the door, and I'm ready to pump the load lock. And I click load lock pump. Now I have to keep the name. We don't have the first one, so we type empty. And then we give other names. You would like to deposit gold on the first 4 sample. And the last line, we verify that we have a cassette inside the load lock, and we click continue load, and the load lock starts to pump. It will take 5 minutes to fully pump down the load lock. And 9 minutes. 9 minutes to pump it. Now you see that the recipe that controls the pumping is finished and it's green. This is okay. And you see that there is a very low pressure in the load lock. So now we can load our sample, the first sample, into one of the process chambers. We have 2 process chambers, the one called PC1 and another is PC3. And there are some difference between them. In the PC1 we have 6 sources. In PC3 we have 3 sources. So now we would like to deposit gold on one of our sample, and in order to do that we have to first run the recipe that puts our wafer, our sample, into the process chamber. For that we go to robot, transfer, and here we click on select source. The source is our first wafer, we call it gold 1. Then we select destination, and the destination will be PC1, where we have a gold target. Click here. So source and destination. Source is the load lock, shelf 9, and destination is PC1, process chamber 1. And we click transfer, and it activates the recipe that brings our wafer from the load lock into the process chamber. So as you see here, we have a load lock, 2 different process chambers, PC1 and PC3. PC3 has already contained a wafer. Once you would like to deposit something, you need to select one of the chambers where you run your deposition process. And the chamber contains different things. As you see, this window contains the vacuum information, and you see the pressure, the base pressure in the process chamber, the cryo pump, the temperature of the cryo pump, and other information. Pressure inside the robot distribution chamber and so on. So in deposition window, this is where you control the deposition. You can do it manually. You can deposit things manually by opening and closing different stuff here, or you can run it through the already designed recipe. These windows contain gases, also window that where you can control the heater of the substrate and motion of different motors inside the process chamber. Now, in the deposition page, you can open and close gas injection valves, and you can control by flow control or pressure control. You can control the gases. We have argon, nitrogen, and oxygen in this chamber. This here you can control the pressure. You can start rotation of the substrate inside the chamber. The power supply for RF bias of your substrate, of your wafer. And here we have different power supply for different sources. We have RF supply, high pins, DC, pulse DC, depending on which source you select. So you can do it manually, first operating with the flows and the pressure, then turning on the power supply, turning on rotation, opening and closing the shutters, and depositing, and then do in the reverse order to shut down your process. Or you can do the same thing by running the recipe, where you can just select certain parameters, powers, pressure, time, and so on, and do it by recipe, which we would like our users to run for safety reasons. So now you see that the transfer is completed, so we are ready. To go. It takes 6 minutes, almost 6 minutes, to transfer the wafer from Loadlock into the process chamber. In transfer, you have our wafer in the process chamber, PC1. So now we would like to run gold, and we have a gold in source form. So we go to run recipe, and then we go and select recipe for DC direct current sputtering. So we go PC1, source 1, DC upstream, and then we click run recipe. So now the window pop up, for that it will record the deposition with this name. Rotation speed for the wafer inside the chamber. Then we select the process pressure, and we start with 4 millitorr. We would like to ramp up our power. It is gold, so it tolerates a higher ramp up, 10 watt per second. And we would like to select the power, which is, in this case, will be 700 watt. We have a 3-inch target, so it tolerates 700 watt. We have also some press sputtering. We will leave it at maybe that makes sure that all kind of moisture or contamination is away before actual deposition starts. And in this case, it will be short deposition of only 9 seconds on our wafer. And we also ramp down by the ramp rate of 10 watt per second from 700 down to 0 before it shut down. And then we continue load, and now we will watch how it proceeds. So now you will see that very soon that this high vacuum valve get closed, and will be gas injection valve will be activated, and the argon flow will be established. Yeah, now you see that high vacuum is not fully open. Very soon the gas injection will open. Yeah, you see it's open now. And now you have a flow control. Very soon you will see some values for argon and for the correct pressure. We selected the pressure of 4 millitorr, but in the beginning it will be 15 in order to ignite plasma. So now you see the pressure rises to 15 millitorr, and it should stabilize for a few seconds. So now it will wait until the pressure is within the spec. Yeah. And now the power supply is activated, and it will very soon select some set point value and turn on plasma. And then it will select our ramp to 10 and will gradually increase power. So now you see the shutter is open and closed, meaning that the argon is penetrated and gradually distributed everywhere, and the plasma is now on. You see there is some DC voltage, and after a while we will see our power will increase to 700. And also you see that the pressure now going to our to the one which we would like to run our process, which is 4 millitorr. See, the power start to increase, and it will increase to 700. You can also see that our substrate is now under rotation.
So now we open the valve to argon, and then we get the argon flow. And this set point set to, we start with high pressure, 15 millitorr here. And then this show argon flow. And then when it's so this is the readout value. And when you get to 15, you could also see in this one, it's check. So now we switch on the power supply. Okay, so now it's initialize the power supply, and then we get the contact to the power supply, and we can see the set point here. The blue one is the set point, and the green one is the readout value. And now, as you can see, now it's set at 30, and then we get 30, and then the forward power also 30 watts, and then we can read out also DC bias here. We actually already ignite the plasma, and after that, then we set the power down to the sputter power pressure, down to the sputter pressure. We want that 3 millitorr. Now ramp down to that. And then we ramp it up, the power up to 120. Yes, and slowly ramp up here. See, this is the cleaning time, and we set it to 120. So it's just counting down here.